Okay, you guys. The syllabus has a new assignment on there, which I've already mentioned. This is due April 2nd, which is next Tuesday. If you've got your fraction class up and running, this one should be really quick. Friday, I'm going to start talking about file accessing, opening files, writing to files, reading from files, etc. I'll continue that on Monday. Here, we'll do a bit of review for this exam, and then the next program is going to be one that I've done before. That's opening a file that has 1 million digits of pi in it and searching for various strings that the user puts in. And then at the end, we're going to switch over and use something called processing. I put a link up there the Friday before spring break, just for people that are curious about what this is. And once you have a basic understanding of programming, especially C, C++ style programming, moving to processing isn't very difficult, and it gives you a chance to play around a little bit with graphics. And that'll be how we wrap up the semester. Today, I want to talk about operator overloads, and then we'll have a presentation from Becca, and then we will talk about something called the constant modifier, which is something that you'll have to use in homework 7. Any questions before I get going? Go ahead.
Have you started grading the fraction class? Or
No.
Alright, so we can resubmit and take our points.
Sure. Yes. Sure. In fact, let me show you how I'm gonna. Let me show you my grading program. Yeah. Where's that going to be? There. I just wrote this over the weekend, so. Essentially, it tests everything that I could think of in your fraction class. And so what I'll do is I'll link this to your fraction class, and I will run it, and then I'll just start scanning through, looking for differences. And if I see a difference, then I'll dive into your code and figure out what's going on. Other questions, Emily?
So if R above and beyond is adding in like another friend function?
You'll have let me know.
I wrote that at the top.
Yes,
yeah.
and then I'll go look at it.
Okay.
Okay, but that will not interfere with this.
Okay.
Right, because this guy relies on the stuff that's in there by default, and if you add something, my guy won't know that. Okay. Rebecca.
So since our next homework is based on this homework, kind of.
Yeah.
Will you tell us if we need to change things?
Absolutely. That's why I grade stuff.
Well, yeah, but you know, like.
I will. Yes. Well, I'll tell you there's a problem here, and if I can say it succinctly, I will say it succinctly. Otherwise, I will just say, yeah, there's a problem with your addition, something like that. Kendall.
Okay, this might be a different question, but so I did like another like function.
Yeah.
And I uploaded my .h file.
Yes.
And the fraction.
Yes. Good.
So you'll get both.
That's great. Yes. So the way I'll do it is if I don't see a .h file, I'll just link it to the default one, and if I do see a .h file, then I'll use yours.
What if we didn't upload a .h file? We just put a comment that we added something. Do you want the .h?
I want it. Yes. Yes. That would be convenient. Other questions? Okay. So we started with the with operator overloads on this running example that we have of complex numbers. And I really quickly, probably too quickly, started introducing these operator overloads. And so what I want to do is a more careful description of how these operator overloads work. The symbols that you see in a C++ program, many of those symbols you're allowed to modify. By symbols, I mean things like addition, things like assignment. You're allowed to change the assignment operator if you want. This guy, the insertion operator, you're allowed to change it. You can't change its default behavior, but what you can do is add functionality to it. So you're not going to be able to change how the addition operator adds two doubles or adds two ints or something, and why would you? But what you can do is teach it how to add complex numbers, or teach it how to add fractions, or whatever, to make your classes that you're writing more tightly integrated into the language. And so we started out with this first example of instead of using the add function to add two complex numbers, like this, which is a bit clunky, C++ lets me essentially bury my addition function inside the plus operator, and then I can use it, and more importantly, the users of your class can use it in a very natural way. So let's talk about that syntax again really briefly. Let's go back here and let's go into complex.cpp. Well, let me first go to complex.h. So if you want to talk about, inside a C++ program, if you want to talk about a particular operator, what you do is you take the symbol that you're interested in modifying, in this case the plus sign, and you precede it with the word operator, which is a reserved word. It's something that C++ understands. So when C++ sees operator plus, it says, oh, you're trying to add some functionality to the addition operator. And if I wanted to add something to the multiplication operator, it would be operator star, division, operator slash. So the syntax is very consistent. Operator overloads like this are never members of the class. They're always just friends of the class. The different operators take different numbers of arguments. Addition requires two arguments in order to make sense, right? You never just add one number, right? That doesn't make sense. You have to have two things in order to add them together. So addition is what we call a binary operation. Binary because it takes two arguments. There are other operators that are what we call unary operations, and they take one argument. Anybody think of an example of a unary operation?
Square root.
Sure. Square root. Sine, cosine, etc. Can you think of another one that's in the C++ syntax? Sorry?
Absolute value.
Sure. I'm thinking negation, right? The dash in front of something negates. There's another one that's maybe you're not thinking of, but the exclamation point. The exclamation point is a unary operator. Okay. Other binary operators that you may not be aware of. Let me go back to main. The insertion operator, oddly enough, is a binary operator. The insertion operator takes the thing on the right and shoves it into the thing on the left. So it's a binary operation. It takes two things, takes the thing on the right, shoves it into the thing on the left, and then the thing on the left does something with it, presumably. Okay, let's keep going here. So we talked about how to do addition. And as I mentioned, if you already have a well-written addition function, it's really easy to create the operator overload for addition. You just use the existing addition function and tuck it inside the operator plus. Okay, let's do a couple more of these guys. Let's do subtraction, for example. So in order to add an operator overload, I have to first put it in the .h file. And now I'm talking about the subtraction operator that has 2 arguments. And we go back over to complex.cpp and we write the overload. And what are the contents of this thing? Well, we could either leave it like it is. This is a perfectly good subtraction operator. Or you could replace it with return sub ZW, like that. Either one is fine. And there are arguments for doing both. I would say the first statement might be just ever so slightly faster than the second statement. Invoking a function like sub requires you to do certain things behind the scenes that might take time. On the other hand, we're using the constructor, which is also a function, and so it's probably a wash in this particular case. No, it's not a wash. I take it back, because this guy is going to call this guy and call this guy, so we call 2 functions instead of just 1 function. So it might be slightly more efficient to use the other one, but there's something elegant about using the existing subtraction operator in this case. And if speed is not a huge issue, and frankly I challenge anybody to really measure the speed difference between those 2 options, it's a safe thing to do. All right, so that's how you would do subtraction. Of course, we've made a change, so we're obligated to kind of test this thing. So let's look at z minus w. And z minus w should give us a complex number -3 minus 3i, or i3, however you want to write it. Wow, did I already do the... No, I didn't. Okay, I didn't think so. Okay, and that appears to be correct. So it's doing the right thing. And you could go through, and let me do that really quickly, go through and do the remaining binary operations. Let's see here, we have multiplication. And we have division. Let's keep those multiplications there. We have division, like that. And then just go over into complex.cpp. Here's our multiplication operator. In fact, I think I'll just grab this guy up here. That ought to work. Looks like it compiles. Let's go over and test. And that guy. And I'll just take its word for it without actually doing any calculations. Remember, it's been a while since we talked about this one, but what are all these guys down here? These 2 guys in particular. Remember where that came about? It makes sense to be able to multiply a complex number by a real number, right? For example, if I have the complex number 1 plus I, and I want to multiply it by 2, it's simply 2 plus 2i. And that's something that a user of your class might want to do. So we built these overloads. One where the complex number is on the left and the double is on the right, and one which is the exact opposite. You would have to do that for all of for your multiplication operator as well, for your overload. So every possible combination of complex, 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 float, float, complex, etc. would have to be dealt with a separate statement. And so when you look at a professional piece of code where they're implementing, say, the complex class or something like that, you'll see literally dozens of these operator overloads. Maybe a half a dozen multiplications, half a dozen divisions, etc., all dealing with these various possibilities. So we're not going to go through that here. You get the basic idea with the syntax, but that's something that a well-written class would deal with. In your own fraction class, I had you write multiplication of fractions, but what is another reasonable multiplication to consider in a fraction class? What kind of constants? 2.5? 2.5? Integers, yes, I agree. I think a reasonable overload in the fraction class would be to allow for multiplication by other integers. Integers, unsigned ints, that sort of thing. Because integers really are just fractions with ones in their denominators. So why not let the user have that and not have to worry about whether they have an int times a frac or a fraction times an int or what have you. So that would be something that you might think about doing for above and beyond, really trying to write out and capture all the possible combinations. Now, you may not think about it, but it's often useful, and I don't know if we have it in this class yet. It doesn't look like we have it yet, but it's useful to be able to compare complex numbers. So you guys have that already in your fraction class. Friend, say, bool, greater than, less than, whatever. We don't really have greater than for complex numbers, right? Or less than for complex numbers. You can't really compare complex numbers. Why is that? Let me pop over to the notes here really quickly. Remember our representation of complex numbers in the complex plane? Looks like this. Let's say we have two complex numbers, a plus ib, and another complex number, c plus id. We can plot those guys. For example, here's a, b, and out here is, say, c, d. These are the two complex numbers, z and w. There's not any reasonable way to compare those to say that z is bigger than w or vice versa. Does everybody see that? There is one comparison, however, that would be useful to have in the complex class. Can you think of one? Well, that's not really a comparison. It's definitely worth having. In fact, we have it in there as the absolute value function. But there is one comparison that we would like. Equality. Right? You can compare two complex numbers for equality. What does it mean for two complex numbers to be equal? What's a test? Exactly. If the real components are equal and the imaginary components are equal. If either one fails, they're not equal. That's a useful thing to have in a class of complex numbers. So let's do that. What should we call it? Let's just call it EQ to start out with. How many arguments is EQ going to have?
Two objects.
What are two of what? Two complex. Okay, so we've got this thing. I have its return type as bool. Does that make sense? Yeah, if they're equal, you're going to get a true back, and if they're not equal, you're going to get a false back. So let's write that guy. Put it down at the bottom here. Get our friendly z and w dummy variables. All right. You could do something like return. I'll be really tricky here. Z dot real equals w dot real and z dot imag equals w dot imag. That ought to do it. How does that work? Well, if the real parts of z and w are equal, this is true. If the imaginary parts of z and w are equal, this is true. True and true is true, and we're going to return that as a Boolean back to the calling object, or back to the calling function. If either one of those is false, false and anything is false. Anything and false is false, so that's going to go back as false. And so there's a really quick way of just returning a Boolean expression back to the calling function, or the calling program. Let's test this guy. So we go back to main. We've got two complex numbers that are clearly not equal. Let's just print out ZW, EQZW. I sent around an email about this earlier in the day. If a Boolean is true, how does it get printed out? It becomes a 1, and if it's false, it gets printed out as a 0. That's pretty standard throughout computer science. In this case, we should get what? 0. Yeah, we should get a 0 to the screen. Let's make them equal just to make sure that the other side is working. Oops. Okay, so now we've built a functioning comparison operator that returns true if they're equal and false if they're not equal. Now we can do an overload and actually use the existing C++ syntax. Let's do that. So we'll go to, where do we go first to build an overload? We have to go to the .h file, right? And we'll just put it down here. What goes here? That's the operator, the double equal sign. All right, let's grab that guy, and now where do we go? CPP. And we'll just put that down here. That should be enough. Looks like it's compiling. Let's go back to main. And we'll, instead of doing that, we'll just return z equals w, like that. So inside the parentheses, you get this comparison, which turns into a 0 or a 1, and then cout will print it. And then let's make sure that we haven't broken anything. That's overloading. All right, let's do a unary. One last one, and then we'll pause and let Becca do her thing. Let's overload the negation operator. So we're gonna let's see, if we want to add negation, we have to go to complex.h first. And I don't remember if we have negation in here. Doesn't look like we have negation in here. That's okay. Friend, let's see, what's negation going to do? What's the return value of the negation operator? It's going to return a complex number that is the negation of the original complex number. So its return type is complex. The operator is that. How many arguments? 1. Of what type? Complex. You might be a little bit worried about how does it know the difference between this guy and this guy? How does it know the difference? It knows by the number of arguments. It knows that if there are 2 arguments, it's talking about subtraction, and if there's only 1 argument, it's talking about negation. So we've now declared the negation function. Let's go over and define the negation function. We do that in complex.cpp. We'll just do it down at the bottom. This is not the neatest code. Do as I say, not as I do. We'll just put our dummy variable in there, z. What does negation do? Changes the sign, and how specifically does it accomplish that? It's got to change the sign on the real and imaginary parts. So we have to build a complex number where the sign of the real part is flipped and the sign of the imaginary part is flipped. How should I do that? I'll start with return. I have a 2-argument constructor. Tell me how to use it. Sure, I could do that. So what's your proposal?
I'm not exactly sure what it would look like.
So you could try something like -1 times z.
So is your sign a boolean like it is for fraction?
Nope. Complex is much simpler. It just has the real part and the imaginary part, and they can have signs.
You need to separate it between. You need to separate them complex number between the imaginary parts and multiply each one. Or can you just
Well, okay. This would in on a piece of scratch paper. This would negate z.
But don't you need to do the real and imaginary parts separately?
Right. I guess my question is, what are my chances of having this work?
Since your estimate is probably pretty low.
What about this? What are the chances of that working? I have the overload for double times complex. -1 would be just a double complex. Assuming I've written that correctly, which I have, this is going to negate both pieces, as you're concerned about, because I've taken care of that in this other function. Could I ever make this work? How? I need to make the operator first. I need to overload star so that it handles a double times a complex. If you're worried about whether you have all of those dependencies, you can also do this. That'll build a new complex number using the negative of the real part and the negative of the imaginary part of z. And then it'll return that complex number. Let's go test that. Let's see if it compiles first. Yay. Let's just let x equal negative z, like that. So what should we get if we print out x? Not that. So I now let x equal negative z, and I'm going to print out x. Yep. Questions about that? All right, Becca, you do your thing, and then I'll come back, and I actually want to talk about overloading the insertion operator, which I haven't had a chance to talk about yet. Do you need the computer, or?
Yeah.
Okay.
So you know what? I made a PowerPoint, but I don't really like it, so I think I might just talk if that's okay.
That's fine.
Okay, cool. So my topic was, okay, there it is. My topic was, what is ICANN and why does the United Nations care? So ICANN stands for Internet Corporation for Assigned Names and Numbers, and it's an American nonprofit organization that sort of deals with assigned names and numbers. So I guess someone gave a presentation on IP addresses earlier. So they're on the website, it says that they coordinate the domain name system, IP addresses, space allocation, protocol identifier assignment, generic and country code, top-level domain system management, and root server system management functions. So in other words, they basically coordinate unique identifiers around the world. And they were created in 1998 by John Postel in response to a policy statement issued by the Department of Commerce that called for a private nonprofit internet stakeholder to administer policy for internet name and address systems. So basically somebody who's outside the government but who doesn't have who's not in it for a profit to just sort of make all the policy for that. And so they've been pretty controversial just because, there's a giant corporation taking care of all of this. So, but some of the stuff they do, last year they opened up applications for organizations to apply for internet addresses, all their own, such as Barnes & Noble got .books. And so now you can, instead of .org, which is kind of cool. And so those sold for hundreds of thousands of dollars. And so they do stuff like that. So the second part of my question, why does the United Nations care? So I guess there's sort of been this power struggle between the two of them. The United Nations, or they've got this organization called the International Telecommunication Union, and they sort of want to take over what ICANN's doing. And so there's been sort of a power struggle there. They want to sort of make, have an international organization that controls the internet, because right now, I don't know, I think there's some other organizations that control it, but ICANN pretty much takes care of the names and numbers part of it. So and so there's just, so if you look these guys up, if you just look up ICANN and the UN, there's just a million opinion pieces on who should be in control of the government. Obama, even in the Obama administration in 2011, said that the UN should probably have more control. And so the latest thing the latest big thing that's happened with this was in December this past year. There was a world conference on international telecommunication, and they were supposed to sort of figure out how this is going to work. And I guess there's this 1988 this treaty on telecommunications that was made in 1988, so it was super outdated, and they wanted to fix it up, but that didn't go super well. And ICANN and the UN were talking about how they're going to change structures to have a more global organization and work together and everything, but then only 89 countries out of I think it's 150 signed the final document, and the U.S. wasn't one of them. And they said that the document had a lot of things against free speech because I guess Russia and China wanted to really change the way the internet was structured. So if you look that up, there's a lot of pieces on how the conference was a total failure. So I guess the most recent article I could find on this was like 7 days ago. It was about the CEO of ICANN. His name's, I'm going to totally butcher it, but it's like Fad Shahad, and his response was sort of that he wants to have more more education about what ICANN is and why there should be more free speech and how that's all great. And so he's sort of making all these efforts to become a more global organization, and they announced that they're going to have this big African expansion, and he's trying to get China to be on his side for more free speech and, I guess, education. That's all I have.
Do you think of a specific example of where ICANN might make one decision and the United Nations might make a different decision? Did you run across any? Like, why?
Not really. It was all pretty
Why should
vague.
we care which one of these runs?
Well, I guess they have very different. For example, in China, they have all these blocking. I guess they block a lot of websites and stuff like that. So they might try and do, since they have more of a say in the United Nations, they might try and do that. Where I guess it's like a bigger committee.
Any questions? Go ahead.
How can ICANN control web addresses? Because can't someone, I don't see how they can say, you get to have this web address, you can't have it.
I don't know. I think they just sort of told them that they could.
Well, that's, if, have you ever heard of the famous PETA.org case? So some guy way back in the early days, he got the web address PETA.org before anybody had web pages or anything. He was running a website called People Eating Tasty Animals. And he had that website 10 years before PETA, People for the Ethical Treatment of Animals, actually wanted it. And they came along and they said, we want this. And he said, no, I've had it for 10 years, you can't have it. And ICANN said, no, you have to give it up. And they gave it to PETA, the PETA, People for Ethical Treatment of Animals. So that's the kind of stuff that ICANN does. They decide who gets what name. So when you ask how they do that, so when you go to an internet service provider, they give you an IP address, a number, and then somewhere somebody has to associate the name with the number. And what happened is this guy had his number and he had PETA.org pointing at this number, and then the real PETA people came along and said, no, we want it, and they had their own number associated with some other computer, and ICANN just goes, and it's all done. And how that happens is something called a root server. There are a dozen or so root servers at the top level of the internet that route traffic from names to numbers.
So ICANN has control of root
ICANN controls the root servers, yes.
Well, we know who they are.
Oh yeah.
Yeah.
It's not a secret or anything. It's just. But at some point they're in a building somewhere and people go in there and they make changes to that. And ICANN people do that.
Did the little guy with the web page, did he actually buy the domain?
Yeah, absolutely.
Oh.
Yeah.
So do they create, like the example of .books, do they actually create the, at the end of the website, .com, .org,
Right, and so that's another thing they do is, for a long time there were very few top-level domains. .com is a top-level domain. .org, .edu, they're all top-level domains. And ICANN is the one that decides how many top-level domains there are and what they are and so forth. For example, you may have read the controversy about the .xxx domain, top-level domain, or the .sex top-level domain. A lot of controversy about whether they should exist or not. Anyway.
Why does that matter? Like, I guess I don't understand why does it matter if it's .com or .x or something. How does that affect the website itself?
It doesn't really. It's just how people perceive and how they find things.
Less traffic, maybe.
Yeah. I don't think it matters as much as it used to. I agree with you at that level. I don't think it matters as much.
So in that example, they created the .books address. Did they sell that to?
Yeah, they sell them. So they create these things. So then somebody goes into the root server room and says, okay, .books is now a legitimate suffix, a top-level domain. And then they start selling, Amazon.books, Barnes & Noble.books, or maybe they sell the whole .books top-level domain to Barnes & Noble, right, for $100,000 or what have you. I mean, it's a, yeah.
So that'd be very easy.
Sorry?
So they're very easily make money basically by creating.
But they don't make any money because they're nonprofit, so they set their prices according to whatever it costs them to run the business.
Where are the root servers? Like, is there one country have more control than another over?
I don't know. Type in like location DNS root servers. See what comes up. Location DNS root servers. I don't really know where they are. Or just where are? Let's say that. It's probably Google probably understands that better. Where are the?
It's a secret.
Google Maps.
Oh.
No, go down. Or, go back.
Looks like there's some in Virginia.
Oh, see them on Google Maps.
Yeah.
Okay, do we want to go back to Google Maps?
One down.
Roll down.
There's an article that says.
Keep going down.
Like the
I'm not.
Right there, right there.
Yeah. that
Yeah.
one.
Oh, okay. Where'd the mouse go? Oh.
How many are there? I have no idea how many there are. I was just guessing.
Click them together.
Put together a visual map.
Where is that?
Down. Yeah.
Oh.
Go.
Oh, I see it.
Oh.
There's a lot.
Okay, so there are a lot more than
There
that.
are not 13.
There used to be very few, but I guess there are
Yeah, we're still in Washington.
many more now.
There.
How much control?
Click on it.
I am.
Oh, and it's not doing anything.
No.
Scroll down.
It usually takes about 24 hours for a change to propagate around the world.
Her.
Perth. Oh no, that's Australia. Seattle.
Big surprise, right? There's probably 10 of them in Seattle. Anyway, thank you. Okay, the thing I want to finish with today is how do you make the insertion operator work? And this is the weirdest one, and it's going to involve something that we haven't really talked about yet. So this is going to be more along the lines of an incantation than it is an actual sensible thing to understand. So this guy, as I've claimed, is a binary operation. It takes the thing on the right and shoves it into the thing on the left. The syntax is pretty similar. I'm going to go over to complex.h, and let's do friend ostream ampersand operator, and then the left guy is an ostream ampersand, and the right guy is a complex. Ostream ampersand, that's a bit mysterious. You know when you want to use cout, you have to include iostream? Cout is an ostream object. Cin is an istream object. And when you load or include IOStream, what you're doing is loading two data types, the OStream data type and the iStream data type, which gives you kind of default access to C in and C out. If you're going to teach C++ how to print something, you have to deal with the OStream object. Cout is an OStream object. So the argument on the left-hand side of the insertion operator, cout, is an OStream. The argument on the right-hand side, I haven't done it yet, but the argument on the right-hand side is, say, a complex number, z. So let's just focus on that pair. So the left-hand side is an OStream, the right-hand side is a complex, and this is the binary operator, the insertion operator. And so that is the declaration. That's this bit here. Forget about this and just look at that. Right? I have a binary operator. The left-hand side is cout. The right-hand side is the complex number. What's weird is the return type. And the reason the return type is what it is to allow this kind of thing. And I remember briefly talking about this once before. The way that cout works with the insertion operator and the way that you're able to chain these things together is it works from left to right. So it looks at the first pair. And it takes z and shoves it into cout, and cout does whatever it does. And then it returns cout. And the reason that's convenient is this whole thing right here turns into cout. And now it's ready for the next thing. It's sort of recursive. So we get that declaration. Let's go over to complex.cpp, excuse me, and let's work that guy out. So we need dummy variables. The easiest dummy variable is just cout for the OStream. And we'll just use our friendly z for the other dummy variable. Now, how do we print a z? How have I been printing my z's? The .print function. So what this guy is going to do is z.print, in other words, print that thing out, and then it's going to return cout. If you stare at it long enough, it makes sense. If you don't want to stare at it long enough, whenever you overload the insertion operator for cout, this is what you do. Let's go back to main in the remaining 1 minute. See if this actually compiles. Sadness. Oh, I know what this is. Now that I have OStreams in here, I have to actually... Oh, no, I have that. I must be forgetting something. What's the error? Ah, maybe I do know what it is. Yes, I need to include IOStream here. That probably even... Nah, that's probably good enough. Nope, not good enough. Probably need a using namespace standard also. Okay, and then go to main. So now, instead of relying on this clunky .print function, I'm just going to print my complex number the same way I print everything else. And it works. And I can actually do two complex numbers in a row. I'll say W. Let's put a space in between them. And it now works transparently. It works the way any other value works. I think we've covered everything. This is in the reading. Let me just check and see if I've forgotten anything. No, next time I will talk about the constant modifier, which is something that you'll need for homework 7. Until then.